Hello everybody, welcome to Tutorials by Decade. My name is Decade, and in this video we are going to start actually building our dungeon. Before I get into that though, if you've liked any of my other videos, make sure you give this one a big old thumbs up. It does help me out, I do appreciate it. Also, if you haven't done so already, please subscribe as I have videos like this coming out all the time, and I do not want you to miss anything. Now that that's out of the way, let's hop into it. So I've already off camera set up our little dungeon entrance right here. So if you don't remember how to do this, you're gonna have to go back a couple videos, and by a couple I mean like towards the beginning, where we set up transitions. Long story short, I have a transition to the dungeon and from the dungeon. So I have my spawn point right there, and the transition to the dungeon is this guy right here. And again, as the theme with most of my videos, make sure you name things correctly. So I've already created the dungeon scene, which we'll hop into in a minute, just called Test Dungeon. So this transition, the target scene is Test Dungeon, and the destination spawn ID is Dungeon 1 Start. And then from Dungeon 1 is the transition back. So in the dungeon scene, I didn't make any changes, but yeah, sure, we'll save those changes. In the dungeon scene, let's go to rooms here. There we go. I just made this simple little room. Nothing spectacular. I made it roughly the same size as the camera. Again, like traditional Legend of Zelda games, the dungeon rooms are a little bit smaller. You can do whatever it is that you want to do. I'm not going to limit it to you. I made it this small, actually make it easier to show you all what I'm doing and what the plan is. So again, I just made one single room, and in this video what we're going to do is there's this door blocking the way, and all that is just a sprite that I brought in, and I made it into a door. Where is my door? Dungeon door right there. All I did was put the sprite here, put it on the correct layer, and then put a box collider on it. And then, yeah, our spawn point is right here. So when the player transitions, they will spawn right there. So the idea is this door will stay closed until all the enemies in this room are dead, or defeated, or whatever wordage you want to use. Now, what I did was I took our slime enemy and I made our slime buddy there into a prefab, so I can just drag and drop these guys wherever I want. Just because I like consistency. Get a 6.5 and then 5. Then where are you at, my friend? You are at 7.5 and 2.5. There we go. So the idea is when the player comes in this room, the player will be able to transition back out if they want to, or in order to advance, they have to defeat all the enemies in this room. So in order to do that, we are going to actually only make 2 scripts. So what we're going to do is find our scripts folder. We're going to go to world, and in here, we're going to create a new folder and just call this dungeon. And in dungeon, oh, didn't want to pull that one up yet. There we go. In dungeon, we are going to create 2 scripts. We'll do the first one now. So mono behavior script, and we're going to name this one Dungeon State Manager. And then we're going to open that up. And in here, we are going to get rid of all this. All right, there we go. And then we're going to do a public static Dungeon State Manager, and then instance. Then we're going to do our get private set. We are going to make this a singleton, so it's going to be persistent. It is going to go across all scenes. And we're going to do private hash set string cleared rooms equals new hash set string. So we're essentially going to store in memory all the cleared rooms. And we're going to do a private void awake, and this is where we're going to make this persistent. If instance not equals null and instance not equal this. We are going to destroy the game object and return. If we make it past that check, then the instance is going to equal this. And don't destroy on load. We're going to do game object. Then we're going to do a couple little functions here. The first one is going to be a public bool is room cleared string room ID. Then we're going to do if string dot is null or white space room ID. Hit enter too many times. There we go. Room ID, and then just return false. If we make it past that, then we're going to return cleared rooms dot contains room ID. That's going to be our little check to see if the rooms are cleared. The room is not in this list, then that means the room is not cleared. Then we also need to do a public void mark room cleared string room ID. And in here, we're going to do if string dot is null or white space, then the room ID. We're just going to return again. And then we're going to do cleared rooms dot add room ID. That's all we're going to do for this. So one small, simple little script. So we are going to go back into Unity. Now here's the thing. Anything and everything that you want to be persistent from start to finish needs to be in your very, very, very first scene. So we haven't done this in any of these yet, but most games, they have what's called like a bootstrap or a bootstrapper scene. That is actually the first scene of the game. You never see it. As a gamer, you'd never see it, but it pops up with everything that is going to be persistent throughout the entire game, as well as some other things that you'll need throughout the entire game. We don't have that bootstrapper yet. That is something that we'll do a lot later down the road. So for now, our very first scene is actually the test scene. And you can tell whatever the scene is, or whatever scene's first, second, third, so on and so forth, if you go up to File, Build Profiles, and whatever is sitting at 0, that is your first scene. So that is where you want all your persistent stuff to go. Now, technically, you can add your persistent stuff in like the house scene or the dungeon scene, but if you do that, it could potentially mess a few things up, unless it is something that is supposed to be persistent from that point forward, which, again, that's something we will cover later down the road. Don't forget, whenever you do make your test dungeon scene, that you have to add it to the scene list. Do that. You can either add open scenes if you're already on the open scene, or with your scene list, you can just drag the test scene over, and there you go. But now that we have our dungeon state manager, we are going to go to managers, right click, create empty, and just type in dungeon state manager. And then the component we're going to add is the dungeon state manager. Easy enough, that is all we need to do there. Now we do need one more script in order for this to work. So in our dungeon script, or in our dungeon folder, we are going to right click, create mono behavior script, and we are going to do dungeon room clear. So once Unity's done doing its thing here, we're going to open up that script. And in here, we are going to put a using system.collections.generic. That way we can do lists and things like that, because we are going to need to do 2 of those here. First, we're going to do header room ID. And then our tooltip is going to be must be unique per dungeon room. We're going to serialize the field. Then we're going to do a private string room ID equals dungeon underscore 01 underscore room underscore 01. That's going to be our default, and this is the pattern that I'm going to use. You can use whatever pattern you want, as long as you understand what it means, and as long as it is unique from every single dungeon room in the entire game. Not just that dungeon, every single room in the entire game. So the way I have it is dungeon, to let you know it's a dungeon room, what dungeon it is, so 01, room to inform you that it is a room, and 01 to inform you it is the first room of the dungeon. Again, that is the pattern I'm using. You can use whatever pattern you want, as long as it is unique and as long as you understand. And if you're working with a team, as long as they understand what it is. Next, we're going to do a header, and then we're going to do locked doors. And then here we'll do a tooltip. The door objects to be disabled when the room is cleared. Why am I doing a list? Well, you might have 1 door. Then again, you might have 3. You could have 4. If you make a weird L-shaped room or a bigger room that has more than 4 doors, you're going to want to put a list of all the doors that you want locked, as well as all the ones that you want opened once the room is clear. So with that being said, we are going to serialize this field, and we are going to create a private list game object locked doors equals new list game object. Just like that, we've created a list, and now we're going to do another list, because this is going to be a header of required enemies. So the tooltip is going to be all the enemies that must be defeated to clear the room. And serialize field, and then private list game object required enemies equals new list game object. And then lastly, we need a private bowl room cleared, and we're going to default that to false. So these should be pretty self-explanatory. Again, the string up here is the room ID. It must be unique for every single room in every single dungeon. This first list here is a list of all the doors we want to open in that room once the room is cleared. The second list is all the enemies that need to be defeated in that room in order for the doors to open. And then this is just a bowl for whether or not the room is cleared. So now we're going to do a private void start. And in the start, we're going to check if dungeon state manager dot instance is not null, and I'm going to hit enter here because this is going to be a long one and I don't want it to go far off the screen. Dungeon state manager dot instance dot is room cleared, room ID. So we're checking to see if the room is, or we're checking to see if the dungeon state manager exists, and then if it does, we're going to check to see if this particular room is already cleared. So if it is, then room cleared is going to be true. And then this is going to give us an error, but we're going to do apply cleared state. Then we're going to return. We'll be taking care of this error here in just a moment. If we check this and the room has not been cleared, then we're going to apply blocked state. Again, this is going to give us an error that we will be taking care of here in one moment. Now, I don't necessarily like to do things in update, but this isn't going to take up much. Something is beeping. All right, we're growing pepper plants, and this time of year we got to get them started indoors, and our heater in the tent is letting me know that it got too warm in there. So if you hear that annoying beeping, I apologize. But my wife is taking care of that right now. Anyway, so as I was saying, I don't like to necessarily do too many things in update because update runs every tick. So depending on what game or what how your stuff's set up, that's it's running essentially all the time. But this does not take up much memory, so it is okay to do this here. So we're going to do a private void update, and we are going to check if the rooms are cleared, and if it is cleared, we're just going to simply return. If it is not cleared, we're going to check to see if are all enemies defeated. That's going to give us an error, but we will take care of that here in a moment. And if they are, we're going to clear room. Also going to give us an error, which we will take care of. So now we're going to do a private bool. Are all enemies defeated? And in here, we're going to do a for loop. Now, I think we've done a for loop before. For those of you that have done any type of programming before, for loops are pretty common. We have for loops and while loops and a few others. We have for each and so on and so forth. So if you are familiar with any type of programming, you're familiar with a for loop. If you are not, and I don't remember if we've done one yet, for loops are something that is going to have to get ingrained into your head because you'll use them all the time. So in order to do a for loop, we do for. And then usually, as you can see, it's already starting to try to fill it out. We usually do int I equals 0. In this case, we're going to do I less than required enemies dot count I plus plus. So to go over what this is, a for loop requires three things. It requires where we're starting in the loop. So in this case, we are starting with I, and it's going to start at 0. And the reason why we're starting at 0 is because a list start at 0. When you put the first thing in a list, it is actually index 0. If I is less than required enemies dot count, the reason why we're doing I less than count is because count starts at 1 when you put the first thing in the list. Once these two conditions are met, we do everything in this bracket. these two brackets right here. We're going to do whatever it is that we type in here, we will do that. And then when it's done, it'll automatically increase I to the next one and run it all again until this statement right here becomes false. That's the only time this loop will break, or unless you manually break it. If you're like looking for something by typing in break. That's usually with an if statement in there, obviously. But we are not going to do that. Instead, what we're going to do is game object enemy equals required enemies, and then in the brackets the I, because that's the index. We're starting at index 0. Then we're just making it easy by naming this enemy, so that way we don't have to keep typing out all of that. So now we're going to do our if statement. So if enemy does not equal null, meaning it exists, and enemy dot active in hierarchy, meaning that we have not defeated the enemy yet. If those are true, we are going to return false. Now, after we've gone through this for loop, if everything passes and all the enemies have been defeated, then that means that we can return true. And that's essentially all we need to do for this, or at least for the all enemies defeated. We still need to do clear room and all that stuff. So what we're going to do now is clear room. So private void clear room. And in here, we're going to change room cleared to true. And then we're going to check if the dungeon state manager exists. And if it does, then dungeon state manager dot instance dot mark room cleared room ID. That way we add this room to cleared room list. And then after that, we apply cleared state. Again, going to give us an error. We are going to take care of that after we do the lock state, which is next. So private void apply locked state. And in here, we are going to check if our locked doors list dot count is greater than or equal to 1, meaning we have at least one thing in that list. If we do, then we are going to do game object door equals locked doors I. Oh, wait. We got to do that in the for loop. I'm getting ahead of myself. Let's try this again. So, sorry, I lost my place here. There we go. So we need to do the for loop first. So for int I equals 0, I less than locked doors count I plus plus. So in here, we now do game object door equals locked doors I. Just like what we did up here with the enemy, we're just making it easier for us to type it out. You don't have to do this step, but wherever you put door here, you would have to actually type out all of that. So now what we're going to do is check to see if door is not null. We don't need to check to see if it's active in the hierarchy or not, because if one door is not, they all aren't. So, and if one door is, they all should be. So if the door exists, we're going to do door dot set active true. This is going to lock all of our doors, so you cannot get through. Going to automatically check. Right? If our locked doors, for whatever reason, don't exist, then we'll just do a quick little else statement here. And in here, we'll do debug.log warning. And then we will do dungeon room clear name. No doors to lock. And that's all we need to do for apply lock state. Now, essentially, we need to do the applied clear state, and we're going to pretty much do the exact same thing, but opposite. So private void apply cleared state. And in here, if lock doors dot count greater than or equal to 1, meaning there's at least one thing in that list, we're going to do for int I equals 0, I less than lock doors dot count, and then I plus plus. And in here, once again, we're just going to copy this. Normally, it's not a good idea to copy and paste things, but I'm just trying to speed things along a little bit, so copy and paste that. And then if for not equals null, then door dot set active false. And that'll obviously go through all the doors in the list. And then we'll do else. And then another debug dot log warning. And then dungeon clear name. No doors to open. Now there is one more thing that we need to do in applied clear state. And we're going to make sure that if we've cleared this room permanently stays cleared. Now, this is something that I like to do for just the dungeons. And later on, we can always clear the cleared rooms if we want to like redo the dungeon for whatever reason. But for now, temporarily, we are going to do for int I equals 0. Actually, since this is the second for loop within this, we should change this to, we'll change it to E. E is less than required enemies dot count, then E plus plus. So technically you could put an I here because it's a separate for loop, but usually whenever you have a, actually we are going to put an I there because this, that's stupid. If you have a for loop within a for loop, you use something other than I. You use something that represents whatever it is you're trying to count. But since this is technically a separate for loop, we can reuse I. So we'll keep I. And then what we'll do is, again, game object enemy equals required enemies with the I there. And then we'll check if enemy does not equal null, then enemy dot set active false. So again, this little block right here is just make sure that the room stays cleared, because if our room is already cleared, then we do not want to have the enemies respawn in here. And that's all we need to do for code. So let us hop back into Unity, let Unity do its thing. So we've already added the dungeon state manager, but now we need to actually add something to the dungeon so that way it can utilize that. So don't forget, in order to change scenes, you do have to save your scene. If you look up here and you see that little star, that means the scene needs to be saved. So on Windows, it's Control S. On Mac, I believe it's Command S. Either way, make sure you save your scene. Then we're going to hop back over to our dungeon scene. And in the room, we're just going to right click and add empty. And we'll just put room ID. And in the room ID, we are going to put our dungeon room clear script. And now we are going to drag our locked door over to locked doors. If you have more than one, drag them all to locked doors. Unless for whatever reason you don't want a door to open. Let's just say you have another door over here and you don't want that one to open. Make players go, "Ooh, I wonder what's over there," and they try to find a way around to get there. Then do not put the door in locked doors. But obviously, to clear a path for the player, you have to put at least one in. But since this is a list, you can put in as many as you need. Same with the enemies. Whatever enemies you need to clear out, drag and drop them in there. Now you can do one enemy, and like if you have a room full of enemies, you can have one and make it random. We're not doing that right now, but you could technically do that. Instead, we're just going to do these two enemies. Make sure you save this scene. To make things go a little bit quicker, you could technically copy the all the managers and drop them in here, as well as the player, and drop the player in here. However, I do not recommend doing that, even though we have all that stuff persistent, and even though it's supposed to delete everything, it could just cause headaches later down the road. So ideally, you want to go back to your test scene. And this is where a debug mode comes in, which we will create a debug mode later, where we can just instantly teleport to any scene or to anywhere on the map or whatever. But for now, we're just going to hit play. For fun, we'll collect that health real fast. And we'll just run up here. We will enter our dungeon. There's our dungeon. You notice this door is locked. Let's see if I can get there. I can't go through it. So let's take out enemy number 1. And let's take out enemy number 2. And as soon as I did that, now the door is open and I can walk through. The camera's not going to follow because I don't have anything more to my dungeon. But now that that door is open, if I come into here and I come back out, I don't know why it spawned me there. You know what? I think I forgot to set the spawn back out. But either way, if we go back into the dungeon, the room remained cleared. Now, it is very important to note that that is only during your playthrough. So now that I've stopped it and I hit play again and I go back in there, you notice the room reset completely. So now I have to defeat these enemies again in order for this room to open back up. So that is how we make our first dungeon room with doors that lock, that do not open until you defeat all the enemies in that room. With that being said, I'm going to end this video here. If you enjoyed it or if you learned anything from it, make sure you give the big old thumbs up. I do appreciate it. It helps me out. If you haven't done so already, please subscribe, as I have videos like this coming out all the time, and I do not want you to miss anything, because that's a lot of stuff to go through if you do something. And with all that out of the way, as always, thank you. Have a good one. And I'll see you